Hey friends, welcome to my channel Ultimate Physics Classes. It's me with you, Raj Bhattacharya, the helping hand or the guide of this lesson. In my previous set of videos, I had covered the chapter Sound of Class 8 in 4 parts, and this is a new part in which I will be covering the next series. There were 4 parts in the previous lesson, and here are 2 parts of the next lesson. Then our chapter Sound will be over, and then I will be solving all the exercises for you all. So, without any further delay, let's begin our this class lesson. So today our matter of discussion is about 5 topics, and the rest 5 topics will be discussed later. So the 5 topics are: how does sound travel? How can we hear sound? What do you mean by audible and inaudible sound? What are ultrasonic sounds? What are infrasonic sounds? And along with that, there is an extra question: what are supersonic sounds? Now, next question is: sound requires a medium to travel. This is the topic on which I will be explaining you. So, let's start. The first thing is, how does sound travel? Generally, we can say that sound travels through compression and rarefaction. Now, what does compression means? What does rarefaction means? Let's explain you with the given diagram. First, I zoom it to the given diagram. Yes, here you can see here's a object drawn. Here come here CR, and this is the object. What does this mean? When sound travels, it travels through vibrating particles. So when the object moves into motion, it compresses the airwave. It compresses the airwave, so the density of that particular airwave increases. Therefore, we can say that the air wave or the air medium gets compressed. Hence, this is called compression. And when this air gets compressed, it transfers the energy to its corresponding or adjacent molecules. As you can see here, this wave is transferring its energy to this part. So here this gets loosened up and gets rarefied. So compression means where the state gets more denser, and rarefaction means where the state gets little bit far apart. As you can see here, where sound travels in the form of compression and rarefaction particles. When the vibration energy is transferred to the air molecules, first it gets compressed, then it relaxes. Again, it transfers its energy to its corresponding. Phase. Similar manner, this gets compressed, and then again it transfers the energy. This gets relaxed, and correspondingly, this system continues on until the sound reaches to the object waiting for receiving the sound. So this way sound travels in a particular medium. So now, first question was, how does sound travel? We can see that sound travels through compression and rarefaction. So where the air particle density is more, we say it to be compression, and where the air particle density is less, we say it to be rarefaction. Now, the second question is, how can we hear sound? For this, you see a diagram on your screen. As you can see here, you see the figure. You can see a diagram on your screen showing the human ear. Here you can see a pinna written here. A pinna actually acts as a filter and receives all this sound and puts it into the ear tube. When the sound enters the ear tube, the vibrations make the eardrum vibrate, due to which the interlocked bones vibrate and transfers their energy to the organ of balance. We can also call that organ as cochlea, which transfers that particular and synthesizes that and converts that into sound and transfers it to the brain through auditory nerve. So this was the structure of human ear. It's very simple. The next question is, what do you mean by audible and an inaudible sound? Very easy. Audible is the sound frequencies which a normal human ear can hear. We can call that to be as audible sound, and inaudible sounds which the normal human ear cannot hear, we call that to be as inaudible sounds. So the next question is, what are ultrasonic sounds, what are infrasonic sounds, and what are supersonic sounds. Supersonic sounds is the extra part. I will also be covering that part. So first one is, what are ultrasonic sounds? So ultrasonic sounds, as you can see written here, the sound frequencies above 20,000 Hz is called ultrasonic sounds. Means the sound frequencies vibrating above 20,000 Hz will be called as the ultrasonic sounds. It is important to know that ultrasonic sounds can't be heard by human beings. Although there are some animals such as dog, bats which communicate on ultrasonic sounds and can hear ultrasonic sounds too. Next one is infrasonic sounds. It is the sound frequencies between the low range of 20 Hz. Means when a sound frequency is below 20 Hz or it is vibrating less than 20 times per second, we will call that to be infrasonic. Now, as I said you here, there is an extra one, that is what a supersonic sound. I have not written it here. I am telling you, supersonic sound is when any object vibrates with a greater speed of sound, that is vibrates more than 340 meter per second. That is when an object vibrates more than 340 times in per second, we will call that to be supersonic. In other words, when any object crosses the speed of sound, we will call that to be a supersonic. Just for example, when a supersonic jet plane come towards you, you cannot hear its sound because it travels faster than sound. You can just see that jet coming towards you, but you cannot hear its sound. Here is the similar case. Now this was about supersonic sound. So now we know about how does sound travel, how can we hear sound, what do you mean by audible and inaudible sound, what are ultrasonic sounds, what are infrasonic sounds, and what are supersonic sounds. Now we are left with the last topic of this video. This is sound requires a medium to travel or propagate. Now why? Now as you can see here, sound requires a medium to travel their air. Therefore, sound requires a medium to travel in air. Therefore, sound cannot travel through vacuum, since without air particles, sound cannot propagate. Okay. So as you can see here written that sound requires a medium for traveling, because without any medium sound cannot travel. Because as I have already told you here about this scenario, the sound travels through compression and rarefaction. Only in air there are particles present. There are particles present. In vacuum there are particles absent. Hence in air particles are present. In air particles are present, and in vacuum particles are absent. Now sound travels through compression and rarefaction. Sound travels through compression and rarefaction. Hence it requires medium for traveling. Hence sound requires a medium for traveling. Sound cannot travel in vacuum. Since vacuum contains no air, hence sound cannot travel through vacuum. Just simple topic. Thank you for watching. If you think this video has helped you and this channel is a helpful channel for you, to subscribe my channel, click on the bell icon aside and like my channel for such videos in further days. Thanks for watching again. The next part is coming soon.